going into part E of lab 14 of the buffer lab. And this is the part where we finally deal with buffers. And as you probably learned in lecture, buffers are solutions that resist pH change. So over here we're going to have three samples. Here are the three contestants over here. First off, we have DI water. Then we have a 0.01 molar phosphate buffer. And we have a 0.1 molar phosphate buffer, higher concentration, lower concentration. And we're going to see which of the three can resist pH change. Is it going to be DI water, the more dilute buffer, or the more concentrated buffer? So we're going to prep three samples for us to try to change the pH. And in order to measure the pH, we need to use these things called pH meters. Over here, you realize that pH meters are submerged in this solution. Oh, okay, there we go. That's because these probes down here, they're not allowed to run dry. So we need to submerge them into some sort of just ionic solution. In this case, this might be potassium chloride, KCl, just to make sure that the very expensive probes down here that are made of glass that can break, and if you dry it up, these pH meters will completely be totaled and wasted. So we want to make sure that they're stored properly. So we're going to pull out this pH meter, and we are going to clean it with some DI water to rinse out the solution. Okay, here's some DI water. And this pH meter is not ready yet. As you can see, there is already a pH reading. Can you see it? See it here? It says 8.5 by measuring nothing. So what we need to do is, for a lot of instruments, it's always the same thing. It's kind of like tearing a balance. We always need to tell the balance, there's nothing on it, please show up as 0. Now for the pH meter, we also need to tear it, or in a sense we call it calibrate it, to have a standard solution to tell the pH meter what the pH actually is. One of the ways to do that is to find a buffer solution like this kind. It says buffer solution, pH 4.0, and this is for calibration purposes. These solutions are prepared to have a very specific pH, in this case 4.0, so that if this pH meter dips into the solution, it should show up as 4.0. So I've taken some of the pH 4.0 solution out, and let me dip this solution into this standard buffer solution. So this is a standard buffer solution. It's supposed to tell the pH meter the proper pHs. So let's take a look at the numbers. It's going down. It should go down to 4.0. And as you can see, it is going down, it is going down, and it's going at 4.1. So we're going to tell it by pressing this calibration button, saying that now I'm going to calibrate you and tell you that this should show up on the pH meter as 0. So it should show up as 4.0. Let's try it again. After a moment of time, it should show up as calibrated. Is it showing up yet? It really should. Let's go back and see if... Anyway, so now 3.9, I guess it's good enough. Okay, let's just say that it's good enough. Now we're ready to use this pH meter. We're going to clear it up. Again, if you were in the lab, you will go through the same process used to. I'm going to dab dry the DI water. Don't rub dry, otherwise you might generate some static forces. It might affect the pH reading. So now this pH meter is ready to go, and what we're going to do is we're going to test the pHs of the three following solutions that we're going to prepare. We're going to set this aside, and we're going to go and focus on the preparation of these three solutions. All right? All right, so next up, the pH meter is calibrated. What we're going to do is we're going to set up three solutions. And and test the pHs when we start adding some really strong base, the NaOH. So first off, we're going to prepare this deionized water solution. In the first beaker, I'm going to prepare the dilute phosphate buffer in this beaker, and we're going to prepare the more concentrated phosphate buffer in this beaker. I'm aware that in the lab manual, you're required to do the first DI water experiment total, and then after that do the dilute phosphate buffer, and then after that do the more concentrated phosphate buffer. But in order to streamline this process, I'm going to show you, one step at a time for all of them. So we're going to have 3 solutions for you to have a more side-by-side comparison. This will not affect you collecting your data, so I hope this works for you. So let's go ahead and prepare the DI water solution first. And so we're going to do that. I'm going to have some DI water. Here's a graduated cylinder. It's asking you to get 50 mils of DI water. So we're going to go ahead and do that. Measure, like we do, measure, pour approximately 50 mils of water. Do you see 50 mils? Is that 50 mils to you? Can you see it? That's 50 mils to me, okay? That's 50 mils of deionized water. And we're gonna place it into a beaker. Focusing good? No, okay, you're just gonna have to take my word for it. So we're gonna place it into this clean beaker, all right? 50 mils of water. There's 50 mils of water inside here. Next, it's asking you to add 3 drops of saturated KCl, just so that the pH meter can pick up the signal better, because for deionized water there's no ions inside, and the pH meter relies on charges to actually have a good reading. So we're gonna put some charge in, right? 1, 2, 3 drops of KCl. And we can stir that in a bit later. If you have a stirring rod, you can stir it. Let's get a stirring rod. That's what stirring rods are for, right? Give it a good stir so the KCl is well distributed in the solution. So now the water solution's ready to go. And what we're going to do is we're going to start adding NaOH to try to disrupt the pH, okay? So I think we can just do one at a time. I think that's fine. So here's water, okay? Now you want to get ready for your chart, because you're going to start filling in the data of your chart on page 8. First off, what's the pH of H2O? We're going to put the pH meter here and going to wait for it to stabilize, okay? So let's take a look. Give it, I guess, 30 seconds to equilibrate. That's a pretty low pH. Doesn't look right. Water's pH should be around 7, and this is not showing up around 7. I hope this is going to be okay. Anyway, your lab instructor will probably give you another set of data, but this is what I have over here. In lab, there's a lot of surprises. It should show up as 7, but it's not. But we'll see if the pH meter is actually doing what it should after we add some NaOH, right? All right, so this is after 30 seconds. You can go ahead and write this number down. If I were you, if I were doing this lab, I would actually write 4.8 down, because that's the number that this pH meter is giving me, although I don't entirely agree with it. But we calibrated it, so for whatever reason, this is probably some pretty acidic water. But next, it's asking you to drop 3 drops of 0.1 molar NaOH into this water. So we'll see if the pH actually changes. If it does not, then we're probably going to need a new pH meter. This is actually pretty new, right? It says 3 drops. Let's see what happens. We put 3 drops, okay? Here's the base. Let's drop the base. 1, 2, 3 drops, okay? Drop the base into the water. And now let's gently, very gently, now we're stirring with the pH meter, which requires a lot of gentleness, otherwise you might break the probe. And let's see if the pH actually goes up. Okay, do you see anything? Let's give it another 30 seconds to equilibrate. What do you see? Is the number going up? Okay, after 30 seconds, record that number down in your table because that's after 0.1 mils of NaOH added. That's the pH change. Do you see a change? Okay, what is it? Write that number down after 30 seconds. We're good? 30 seconds? Right, so next up, step 4, it's asking you to add another 0.9 mils. So effectively, you'll be adding 1 mil total. And to do that, you need to count 27 drops. So let's go ahead and count 27. Okay, let's count this together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27. Okay, I should stop there. I almost went to 28, but you know, you get carried away really easily if you're not focusing. And that's what's going to happen in lab. That's what happens when you're watching videos at home too, right? It's like the phone is so interesting. There's so many other web pages that you can go to. But you decided to just stick with this and admire that. That's really good. Okay, let's take a look. Let's give ourselves another 30 seconds and write down the pH after that amount of time. Okay, what do you see? Did the pH change? Write it down. Write that number down. We're good? All right, so we're going to prepare the last blow for this water, which is to add a total of 10 milliliters into the solution. And since we already have 1 milliliter there, that means in order to add a total of 10 mils, we only need to add 9 more milliliters to the solution. So I'm going to go ahead and get our 0.1 molar NaOH, get the amount so that we have 9 milliliters in total. 9 milliliters, because we already have 1 milliliter inside our water solution there. Hope that makes sense. That's how you get to adding a total amount of 10 milliliters. I think my eyes are failing me. Okay, what do you see? Do you see 9 more mils? Do you see 9 mils over here? Yes or no? Is it visible? It's barely visible. Yep, anyway, that is about 9 mils. Well, let's go ahead. Let's go ahead and add 9 more mils to the water and see what that does to the pH, right? See what it does. That's 9 more mils over there. Let's give it a good stir. Very gently, again, the pH probes are very expensive, especially the glassy part in the bottom, so you want to do this with lots of care. Okay, what do you see? Okay, let's give it another 30 seconds to equilibrate and write down what you see. Did the pH change after an additional addition of 9 mils of NaOH? All right, you decide. It's great. Very good. All right, so this wraps up the first 4 data sets of this table. So water, pH of water with nothing added, with 1 mil added, that's 3 drops, 0.1 mil, that's 3 drops. With 1 mil total, that's 30 drops, so that's why you added 3 and 27 drops. And then another additional 9 mils gives you 10 mils of base added all together. Next up, we're going to do the same thing to these two buffers. So let's get ready for that. All right, so now we have figured out what happens to the pH once we start adding NaOH to pure water. Let's find out how the pH, how the pH would change if you're adding the same base, NaOH, to these buffer solutions. So we're going to have the exact same setup. Now we're going to have, instead of 50 mils of water, we're going to have 50 mils of 0.01 molar of phosphate buffer. So let's go ahead and get 50 mils of that. All right, so let's go ahead and do this. I'm getting close to 50 mils. Now I'm going to use the pipette to get myself 50 mils of phosphate buffer. You guys see it? I can barely see it. I hope you can see it. Very carefully. Yep. That 50 mils. Yep. Just a couple more drops would do. That's 50 mils to me. All right. So now we're gonna pour 50 mils of 0.01 molar phosphate buffer, i.e. the more diluted buffer solution here. And we're gonna start tossing in some NaOH, okay? Just like the same deal. So I'm gonna go ahead and stay quiet and let you do the reading, okay? Now this is the phosphate buffer. Let's give it some time to equilibrate. While you're watching this, I'm gonna go ahead and start preparing the NaOH solutions. With this solution, we're going to do the same operations. We're going to add 3 drops, read, 27 more drops, read, and then 9 more mils, and read again. So we're going to do that. So now this is the phosphate buffer reading. You can go ahead and write whatever you see down. And now we're going to add 3 drops of NaOH. 1, 2, 3. That's 3 drops. And we're going to give it of NaOH. Yes. We're going to give it a good stir. I'm going to ask you what you see. What do you see? Okay, observe. Pretend that you're doing this. Next, we're gonna try to deliver 27 more drops, right? So we have 30 drops, which roughly equals to 1 mil. So let's go ahead and deliver the 27 drops. Let's count very carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, oops, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, that's 27 more drops. And let's give it a good stir. And what do you see now? Is there a change? Did anything happen? What do you see? Okay, let's go ahead and give another 30 seconds or 20 seconds. Do the reading. Yeah. Is this visible? All right. now we have a good idea of adding, you know, a whole milliliter to it. Now let's add another 9 milliliters. So we can add it up to 10 milliliters added into the buffer solution. Let's give it a good stir again. All right, and now let's allow it to equilibrate. And what do you see now? Go ahead and look at it. Did the pH change? Did anything happen? Write the number down. Again, this is the pH of the 0.01 molar phosphate buffer when you add an additional 10 mils total of NaOH to the solution. This is what the pH turns into. All right, so that pretty much wraps up this part. The next part, we're going to take a look at a more concentrated buffer and see what happens to that buffer. All right, so this is the last part of this lab where we're trying to destroy or exhaust the buffers. Now we're using the 0.1 molar phosphate buffer. So it's a more concentrated buffer, and we're gonna also try to get 50 mils of it. So I think we roughly have 50 mils. Let me just add a couple more drops. We have 50 mils, at least from my reading. And this is 0.1 molar phosphate buffer. We're gonna go ahead and transfer the buffer into the speaker. That's the buffer. Now we're going to go ahead and measure the pH using this clean pH meter of this buffer. This is the more concentrated buffer. Let's go ahead, let it equilibrate, let the pH meter have time to detect this. I'm going to prepare the sodium hydroxide solutions. Time, because I now know that I have to add 3 drops, 27 drops, and then 9 mils. So I can go ahead and get the last part done so I have a more smooth transition. It's the 9 mils of NaOH that I'm going to use eventually. But have you got the readings down yet? I hope you have. Right? So now the reading's down. This is the initial just phosphate buffer. And we're going to try this buffer by adding 3 drops first. We're going to see what happens to it. All right? 3 drops of NaOH. 1, 2, 3. Okay, that's 3 drops of NaOH. Cap it back up. And let's give it a good stir. All right. What do you see? Give it some time, 20 seconds, 30 seconds. As long as the number's not jumping around like crazy. As long as you're consistent on when you take the measurement, we'll call it good. All right, so are y'all good? Let's move on. Let's continue to try to shift the pH around by adding this really strong base. Let's see if we can do that. Okay, this is what we're going to be doing. We're going to be adding 27 more drops. Again, counting to 27. That's a lot of numbers. Let's do that. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right? Very consistent. The second time we add, we always add 27 more drops. So let's give it a good stir again. And take a look at the pH. You see it? Yeah. Go ahead and give it 15, 20 more seconds. And write this number down. This is after we added 27 more drops, so effectively 1 milliliter of sodium hydroxide is inside. All right? So if this is looking good, let's move on to the last part where we add an additional 9 mils, which means in total we have added 10 mils total of sodium hydroxide. Let's give it a good stir. All right, it's good. And now let's read the pH again. Do you see a pH change? What do you see? All right, so go ahead and write the data down in your table, or based on the data that your instructor provided. And then you can figure out which solution actually can resist pH change the most. There is one solution that just stops the pH change altogether. And what solution is that? I'll let you figure out, draw the chart, and you'll see which buffer has the highest capacity and what solution, what liquid has the least resistance to any pH change. All right, good luck on wrapping up this lab.